Hey there. You're probably watching this video because you're interested in Kubernetes and you're running pods, which is basically every workload in Kubernetes. But there's something that's subtly different between the day one pod that you run that just works and then a mature, feature complete, production quality application. There's a lot different that goes on in the pod spec. So over the years, I have sort of created my own setup of what a pod spec might look like. And that led me to this repo and video, pod spec good defaults. I don't say best practices. I don't like to say best because a lot of this stuff depends on your workload, your security approach, how you need to deal with uptime, and the application itself and what it needs. But these are the most common features that I enable inside of a pod spec for every workload that I need to run, particularly ones that we're making ourselves on our own languages, right? If we're running Python apps, Ruby apps, .NET apps, Node apps, all these things that I'm running in my own containers where I'm customizing the Docker file. There's a lot that can go into the pod spec, not just the Docker file itself, but we'll talk about that as well. Let's jump in. So the repo link is below this video, but you just go to my GitHub where I have a bunch of other good defaults. I have Dockerfile good defaults. I have Node good defaults. I have an older PHP good defaults. I have GitHub Action good defaults. I have all these good defaults. And this is now my next one, really, the pod spec, which we have to create for everything we do in Kubernetes. There's really only one file that we care about in this repo, at least currently. That's the pod.yaml, which you can take this pod spec and nest it inside of deployments, daemon sets, stateful sets, any of the other ways you run pods. They all have a very similar pod spec. In fact, the pod spec itself doesn't change. It's just the outer YAML that wraps around that inside of your particular deployment type. That stuff might change the number of replicas, the different features of that particular thing, like a deployment. But your pod spec is really going to stay the same. And there's other things we will talk about in other videos, like init containers that start before your pods containers will start. But we're just going to focus on your main app in the pod itself and the things you need in the pod spec and in that containers specification, at least for most workloads. I'm going to walk you through this pod.yaml step by step, and we're going to start with the boilerplate stuff, which if you're doing a pod, you're going to have the API kind and other things up at the top, but you're probably going to be copying this into a deployment. That's usually what we're doing, right? So let's get down beyond the name and image, which of course we have, and of course you shouldn't be using a reusable tag and all those things, but it's the ports is the first thing, and it's optional, but I still recommend you put it in there. You can technically skip it, and Kubernetes will look at the expose stanza or the expose command in the Docker file metadata to find out the ports. But I like to have it in here anyway, and you'll see that with a lot of these things, they're often unnecessary in terms of having to be there in order for them to function. But I prefer that my Kubernetes YAML, especially when you have multiple teams dealing with it, I prefer to have that Kubernetes YAML be more descriptive about exactly what's going on. You may have a security or DevOps or operations team that requires some of these things, even though you can get away without them. And that's the case with the ports. I still like to put it here. By the way, you'll notice that later on, because we're going to run as non-root, you have to use a port higher than 1024. And so port 80 here and 443 wouldn't work in the container because we're not going to run it as a root user. And that's a thing about Linux is it tends to prevent you from using those low ports. But the standard here of 8080 will safely work in all those scenarios. So that's what I'm going to stick with. Next up, the probes. Now, the probes are a source of opinions, and I have my own. I'm not saying these are the only opinions that matter or that they're even the best ones, but I do have years of experience in running production workloads like this. So I've tried lots of different scenarios. I've tried different ways of doing it. Absolutely, the only requirement I insist is that you have one. You have at least a liveness or a readiness at minimum. You need something in there to give Kubernetes the intelligence around the status of your app. When it comes to readiness probe, over time, it has become my favorite probe. Liveness probe is kind of what Docker has built in for itself in Swarm and Compose. But the liveness probe, I have a mixed feeling around, because if you're too aggressive with having it happen all the time, maybe every 5 seconds and only a 10-second timeout or 5-second timeout, or the default of 1-second timeout, the liveness probe can actually cause your app quickly to get killed by Kubernetes. A great example of this that I see every once in a while are people that use traditional monolith apps that maybe generate some sort of report, or they do some sort of file ingestion, and they take a long time, meaning minutes, to maybe do that on really large files. And maybe they're in a language that's not well threaded, like Node.js, where you have one thread by default. And so the liveness probe can fail because the app is too busy. And so I don't like that. I really never want my app to be killed, especially nowadays in most of our modern languages. If there's ever a problem in your language, it tends to just crash. It doesn't usually freeze like this liveness probe is meant to help you recover from if your app becomes unresponsive. But in my experience, I don't really see that with a lot of the apps I work with. It's usually the apps are crashing because we hit a particular bug in the code, or it's just really busy because it's single-threaded, or it's capped by some resource that it can't access more of, like CPUs. So the liveness probe for me, honestly, over the years has not proved extremely valuable. The readiness probe, in my opinion, has become even more valuable. I used to only use this for applications that had a listening port, and that readiness probe will help me ensure that it doesn't put this application into the service endpoints when it's not ready yet for new connections. Well, I've recently learned in the last year that there's even another benefit for this when you're doing rolling updates, even if it doesn't have a listening port. So if you're using a worker process that doesn't have a traditional listening port, we used to just say, you don't need a readiness, just use a liveness. But readiness will help ensure that that app is ready before the replica set resource goes and starts to tear down the next pod in its list. If you had, let's say, 2 pods, 2 replicas in your replica set for your deployment, and the first one was coming up with its new pod, its fresh new image, or whatever you've changed, and there's no readiness probe, then it might not realize that that app isn't ready yet. Maybe your app takes 10 seconds to really get started once it's been executed, and it's going to go to the next pod immediately without a readiness probe and start to shut down that second pod before the first one is technically ready, which means in that case that your app, even though there's no listening port, that particular replica set is now down completely because you only had 2 pods. One's not ready and the other one's getting ready to shut down or starting to shut down. So I am a fan of readiness probes in every case that you can use them. And if you don't have an app that has a listening port, one of the best things you can do here is to rewrite your app a little bit to basically write or touch a file somewhere on the file system in the container. That can even be a temp fs location that's only in memory. And then your health check probe here would just check that file. It would run an exec command to check if that file was dated within the last 30 seconds or whatever your period is for that check. And so that's an easy way for you to take an existing app that doesn't have a listening port and make it ready for a readiness probe. All right, enough about probes. Let's get to resources. Now, you probably, if you've ever run a scanner or any sort of YAML check on your Kubernetes manifests, it will complain if you don't have resources. So requests, there's really no bad about requests. You should always use them. I keep them fairly small because I don't want to reserve, because that's what requests do. They reserve the resources. I don't want Kubernetes to reserve more than I would need in every scenario. So I tend to keep these very low, very conservative. The limits are where I have some mixed opinions. So a couple of things you'll see here. One is I've commented out the CPU line. And there is some mixed opinions around ever setting a CPU resource limit. Because if you set a limit, you might end up with just other CPUs that aren't even being used, and the application is arbitrarily limited in this particular pod because we've set a limit. So some have the view that you really, in almost all cases, you shouldn't set a CPU limit. A memory limit is really just to prevent an out-of-control application that maybe has a memory leak or something from eventually taking over the entire host memory. I do agree that you probably want to set this pretty high at first, and then over time, as you learn your app, you start to bring that down to a more reasonable level. With CPUs, the one reason you may want to enable the CPU limit is if you're going to set your requests and limits at the same numbers. When you do that, and you set it for both memory and CPU, then your quality of service in Kubernetes is marked as guaranteed. If you haven't read up on QoS, then there's a link in this repo for what Kubernetes QoS is, but there's 3 different policies or settings that it will apply. And the best one is guaranteed, which means that it will be the last thing on the cluster to be tore down to make room for more apps. And now most of us in production don't end up having any of these quality of service issues because we usually have enough nodes and resources there so that we don't have resource contention. But in really large and busy clusters where easily someone in a different team could be loading up a lot of new apps, and your apps could possibly be killed when their resources aren't fully set or when the limits and requests are different. So read up on QoS. Next up, we're talking about per container security settings. In this case, we're disabling the ability for our app to have privilege mode, kind of like privilege mode in Docker. Technically, false is the default, so we don't have to set it here, but this may be a checkbox in your sec team or devsecops team for making sure and insisting from the Kubernetes side of things in this YAML that you set that, because if you were ever to set privilege true, they'd want to prevent that from running in the cluster. The other setting here for allow privilege escalation is there to prevent you from sudoing in the container, or more importantly, for the bad people that might be able to get into your container to run sudo inside that container and do things like install software or change some of the binaries inside that container while it's running. And most of us don't need to allow privilege escalation, so why not set this false as another way to lock down the container? Next up, let's talk about termination grace period. Now this comes back to more around those rolling updates that you deal with the probes. And so many people focus on the startup of your applications in containers. I say that equal amount of attention needs to be focused on the shutdown, especially if you're someone who's working in an application that's required for high uptime, where you're maybe deploying on a daily basis and you don't want users to even know that you replaced the container. In order to do that, you really need to fine-tune your shutdown process. And if you have listening ports, that even gets harder to do, especially with HTTP, where we have many different ways for long connection times, where you have either long polling on HTTP or you have WebSockets or some other mechanism that creates a long-standing TCP connection. In these cases, and that's quite often the case for HTTP connections, you want to extend the grace period, which is 30 seconds, because your application, hopefully, is going to be aware of the connections that are happening right now, and it's going to need to tell them, hey, you're going to need to reestablish your TCP connection. That's called a FIN packet, and you're going to need to start on a new connection, which Kubernetes will correctly route to a new pod that it just started. In this case, we might need 5 minutes. We might need an hour for our application to ensure no users are uploading or downloading files, that a report isn't being generated in the background. All the kinds of things that could take minutes, possibly even hours to do, we want to take into account in our grace period. You will need to test this to ensure, if you're new to all this stuff, to ensure that your application is properly shutting down and taking care to make sure no one's left hanging in the middle of processing a file or doing something on your website when it shuts down the container. And if you haven't tested it, then that probably means your custom app you built is terminating connections without gracefully disconnecting them. Every application programming language I've looked at, unless you're using specific frameworks like Stoppable in Node, and everyone else has their own. But if you're not using one of these special connection tracking and handling modules in your app to make sure that it properly sends a TCP FIN packet, allows the connection to gracefully reconnect to a different pod, then you're probably in trouble and you need to do some more research. All right, next up, we're going to be looking at per pod security context. We did look at security context for a container, and some of these settings can be in each container, because again, your pod can have more than one container, and it could be individual settings per container, or some of them will allow you to set it for the entire pod. I'm showing you both in this case. Some of these are required to be in the pod spec. Some of them are sometimes required in the container spec. So it just depends on the setting. In the first case, seccomp profile. I'm a big fan of enabling this, and there's rarely any reason not to. Sadly, it's not on by default, although coming in an upcoming release of Kubernetes is a way to set this as default for the entire cluster. But until then, we're going to need to set it in each pod spec. I am a fan of always enabling this. If you didn't know, Docker Engine has been enabling this since the beginning by default on every Docker run. It just so happens that Kubernetes disables it, and we really want to take advantage of reducing the amount of kernel syscalls that our application can run. And that's really what this security computing feature does, is it uses a default profile that comes with the runtime, whether it's containerd, Docker, or CRI-O, and it will enable that to reduce the number of elevated syscalls that your application could run from inside the container. Then we have the run as user and group, and these settings are ones you can specify, at least for the user, inside the Docker file. And you're going to need to do that if you want to play with these. I recommend always setting these. Again, we're trying to not run as root in every case possible. But if you're going to run as non-root, especially in your custom applications, you're going to need to set that up first. So go back to your Docker file. You're going to need to use all the changes in there, like setting the user stanza or copying in your files with the chown option when you use a copy in Docker file to change the file permissions and make sure that your app will run as the non-root user. Then, once you've set that, you can also set run as non-root equals true. Now, technically, there's a couple of ways we can do this. It is possible to just set the user in the Docker file and then trust that Kubernetes will not run it as a root user, which it will obey the metadata settings from your Docker file. But again, security teams, devsecops teams, they may require that the user and group be hard-coded in here to guarantee that even if the Docker file changed, that it would never be run as root on the system. The run as root here on line 56 is that guarantee. If we set it as true and go back and set the line 54 as root, or 0 for root user, it would not work. It would actually error out and say, I can't do that. I'm not allowed to run as root. So this is a guarantee on line 56 to ensure and safely run our application. And your ops team may enable a feature in your cluster that acts as a emission controller to prevent anything from running as root. Even if you try to change these settings, it'll just fail. But one of the things I'm showing you here is on line 54 and 55, I set the user 1001. Typically, the examples and demos and the things that I would show you in the past would show user 1000, but I've run into a couple of cases where that user is indeed already used, and other people in the community have also expressed that concern. So I'm showing you user 1001. You would need to create this user and group in your container. You can go also look at the default Docker file for MySQL, Postgres, Node. All of these different official Docker files have the lines you would use to create the user and the group. You can go grab those, set up your Docker file the way it should be, test in Docker as a non-root user, and then once that works, you bring that into this Kubernetes by setting these 3 lines. Now, there are some factors and complexities around these that I didn't even specify today. Some of those I'm adding to the README as people in the community bring it up. So I've shared this on Twitter, got a lot of discussion there, and people have brought in more information that I didn't realize. So I've been adding that as I go. So for you, I have 2 assignments. You have 2 things I want you to do here. First, I want you to actually try to use this. I would like you to see if you can improve your own pod specs in your applications by adding one of these things that you don't currently set as a standard. And that's the goal here, is that we come up with a standard in your team for your apps that you can rely on that's pretty consistent between your different applications, at least consistent between applications of the same language and type. And 2, I'd like your feedback. Comments below, preferably issues and PRs in the GitHub repo, either way, or just reach out to me on Twitter and tell me if you disagree, because these are a lot of opinions that I've had over the years of running Kubernetes apps. So it might not be the best opinion or the correct opinion. So give me some feedback. Let me know if you like it, if you think it's missing something, if you disagree with something like one of my health check opinions. If you disagree with that, please let me know and why, because I learn a lot from the community, and that's where a lot of this comes from, is everybody coming together, and then we create some sort of consensus. I try to use things, I try my clients to use things, and then we find out that it maybe is operating differently in production than as advertised. So let me know. And thank you so much for watching this video. See you in the next one.